Global warming, the doom and gloom. Over the last 100 years, the average temperature of the Earth has risen somewhere between 0.4 and 0.8 degrees Celsius, an alarming rate which continues to climb. Through human activities such as the burning of fossil fuels, land clearing, agriculture, etc., increased volumes of carbon dioxide and other greenhouse gases have been pumped up into the atmosphere with nowhere to escape. There have been, and will continue to be, many effects as a result of this, such as the gradual melting of the polar ice caps, causing sea levels to rise and putting many people at risk, especially in the Pacific Islands. However, one other effect of this global warming is ocean acidification. We need to find a way to combat the imbalanced pH of the ocean. The ocean has always absorbed carbon dioxide through its uptake of the chemical through physical processes such as waves and temperature. When it combines with water, it forms carbonic acid. This breaks down rapidly into bicarbonate and hydrogen ions. These hydrogen ions combine with the carbonate in the seawater to form more bicarbonate. It is through this natural process that the ion concentration and subsequently the pH levels of the ocean had been maintained for thousands of years. However, global warming has unbalanced this natural process. As we have increased our carbon dioxide emissions, the gas enters the ocean at a faster rate than before, and the natural supply of carbonate in the water cannot keep up with the excess hydrogen ions. This is particularly prevalent in coastal regions and the deep ocean. This has resulted in an excess of hydrogen ions, and the pH and carbonate are decreasing. This decrease in pH means the ocean is becoming more acidic. This acidification has many effects on the oceans and marine life. A lot of marine creatures, such as oysters or the ecologically critical coral, are struggling amid this decline in carbonate availability to maintain their calcium carbonate shells. Many larvae are being majorly affected, as they are not able to grow or develop shells normally, and juveniles have reduced growth, thinner and eroded shells, and severely reduced survival rates. One national implication of this is that if our power larvae do not survive here in our industry, it will only be a matter of time before power become a mined resource, or rather, unable to replenish its populations. Similarly, coral reefs are being heavily affected by ocean acidification. Unlike shellfish, for example, coral colonies last many hundreds of years, becoming a fantastic ecosystem for many other forms of marine life, particularly serving as nurseries to small fish. However, their long lives means it takes them a very long time to grow. The massive corals are the slowest growing of all, 5 to 25 millimeters of length per year. Similar to the shellfish mentioned previously, coral larvae attach themselves to rocks to begin growing. From there, the coral polyps secrete their exoskeleton made of calcium carbonate. Growing the skeleton takes a lot of energy. However, much more is required to compensate for the decreasing amounts of carbonate in the water. The significance of this is that coral reefs are valuable habitats to fish and other marine life, serving as food sources and nurseries, as well as looking amazing. With the struggles that coral colonies face, this will directly impact countless other marine life, putting them at much danger. Now, it must be recognized that ocean acidification isn't entirely bad. Some marine life, such as seaweed, thrives in this sort of environment, meaning there are population growths to some forms of marine life. Some groups will actually find this environment better suited to them. However, there are simply too many changes we cannot yet know of, and therefore it is better to act and try and preserve what we have now. This is because oceanic environments, such as coral reefs, provide biodiversity, something that is key to an environment. Ocean acidification will decrease the biodiversity we currently experience in our oceans. One solution is to introduce more carbonate into the oceans to combat this decrease in pH that is leaving this imbalance between it and hydrogen ions. Now, this doesn't mean we ought to break down the White Cliffs of Dover. Instead, we must turn to other sources of carbonate. Every year, tons and tons of mussel shells, made largely of calcium carbonate, are being taken out of the ocean and end up in landfills. Essentially, we have a fantastic source of carbonate on land that could be reintroduced to the water to combat the acidification. To implement this idea, one would dissolve the shells and introduce the carbonate into the water, similar to how the carbon dioxide makes it into the water. Targeting key areas such as river outlets and coral reefs would be both practical and achievable while providing the greatest ecological and economic benefit. This idea has social and economic benefits to New Zealand as well. Not only would we be a leading example to the world, showing that we care for our oceans and the biodiverse marine culture within, but we would also have the opportunity to create many jobs and, more importantly, secure our current fishing industries. This idea has the opportunity to create jobs for people to collect shells from landfills and other places they can be found and introduce them into these selected and protected systems. However, we must also recognize that because of the lack of carbonate in the ocean, this will directly impact many of our stellar fishing industries, such as our crucial power market, something that could cripple the industry, losing jobs and putting strain on the economy. Implementing this idea would have far-reaching benefits for the economy, employment, and the environment. To conclude, ocean acidification is a product of the rising carbon dioxide emissions over the last several hundred years and poses a threat to many marine species, including coral, which provides many other forms of marine life with food and nurseries, and shellfish, a source crucial to our economy. To combat the imbalance between hydrogen ions and carbonate in the ocean, one solution could be to introduce more carbonate from sources such as waste shells in areas that need it most. This would save or create many people's jobs and ensure the stability of the economy. The problem is complex, but this solution is a basic one worth investing in. Thank you.